Hello everyone, welcome to session 2 of module 3 of measurement and instrumentation. So in the last module we have discussed about the basic of a potentiometer, what is meant by potentiometer, why it is being used, what is the uses, where it is applied, and then a basic slide wire potentiometer we have discussed, which is the basic of all the types of potentiometers. Now we will see about the types of potentiometers. So in general, we have two types of potentiometers. So based on the voltage it measures, whether it is DC or AC, it is divided into two types. We have DC potentiometers and AC potentiometers. So in today's class, we will see DC potentiometer and one type of DC potentiometer. So we have two types of DC potentiometers. As we already know what is a potentiometer, it is a meter measuring instrument used to measure unknown voltage by comparing it to the known voltage. So if you want to define a DC potentiometer, then it is a measuring instrument which measures an unknown DC voltage by comparing it with a known DC voltage. So we have two types of DC potentiometers. One is the Crompton type, or we can say it is the laboratory type DC potentiometer. The other one is Vernier type. First we will see Crompton type potentiometers. So the basic behind all the potentiometers is the slide wire potentiometers. So if we have a clear idea about the basic slide wire potentiometer working, then it is easy to understand the rest of the types of potentiometers working. So here a Crompton potentiometer is given. So a Crompton potentiometer circuit diagram is will be like this as shown in the figure. So you have two set of dials. One dial will have 15 steps which provides the resistance to the circuit. The other circular dial which is used to display the voltages or the unknown voltages. So the first dial, which is like a star shaped, consists of 15 steps, and each dial or each step have 10 ohms of resistance. So totally it is 150 ohms, and a total voltage drop across this dial 1 is 15 volts. It is connected in series with a source voltage denoted by E, which in turn is connected to the rheostat. And the dial 2 is a circular type, a slide wire, which is like a dial, but it is not a dial. It is a circular slide wire of 10 ohms, and it has 20 divisions. So it is like a scale. So it is in a shape of a circle. It has 20 divisions, 200 divisions, and each is of 0.005 volt. So the total is 0.1 volt. So it is connected to, and the rest of the secondary circuit consists of an unknown EMF, and we have a standard cell for calibration, and between the primary circuit and the secondary circuit the switching operation is done, that is to calibrate, and after that we need to find the unknown EMF. So we have a primary circuit which consists of the calibration part, and we have a secondary circuit which consists of the unknown EMF cells. So to switch over between these two circuits, we have a DPST here which operate between these two points. So which is connected, the DPST is connected to another switch K, and we have a galvanometer G for showing the null deflection, and we have a sliding contact along from in series to the galvanometer, which moves over the circular slide wire. So the Crompton laboratory type DC potentiometers uses a calibrated dial resistors and a small circular wire of one or more turns. So in previously we used a long slide wire, which is the basic slide wire potentiometers, but this reduces the size of the instrument because the slide wire is kept in a circular manner. So as we seen in the figure, we have a dial resistors of 15 steps, and the working current in the dial resistor is 0.1 volt. Working current is 10 milliamps. So the potentiometer is provided with a double throw switch to make connection between the standard cell or unknown cells. So to operate the galvanometer at its maximum sensitivity, provision is made to short the protective resistance near the balance conditions. So the basic operation is that for calibration, the DPST is made to switch between the standard cell. So when it is connected to the standard cell, the slide wire is moved to the entire circular slide wire, so that the entire resistance get added to the circuit. We can find the total voltage drop across the unknown wires, slide wire. And then after calibration, the DPST is connected across the unknown EMF source, wherein which the unknown EMF cell gets added to the circuit, and then by moving the jockey over the sliding contact over the circular wire slide wire, we will attain null deflection in the galvanometer. After getting the null deflections, it is very easy to find the unknown voltage because it is very visible in the circular slide wire, which is already has provisions for viewing the voltages. So the voltage values will be displayed in the circular slide wire. So from that we can easily find the unknown EMF. So this is the working of a Crompton type DC potentiometers. So in the next video we will see what is the other type, which is the vernier type, and how it works.